2.6, scatter plots and linear inequalities. So a scatter plot is a graph of a set of data pairs. So we're just going to look at some data pairs here. So let's look at this one. Okay, those data pairs would be said to have positive correlation. Those would be said to have negative correlation, but the correlation is tighter. And we'll look at that in a minute. And I know you've seen graphs that would be no correlation. There's no relationship at all. So we have this thing called a correlation coefficient. It is referred to by the letter R, and it's a number between -1 and 1. It measures how well a line fits a set of data pairs. So this should say line fits a set of data pairs. So let's just look at okay, these have a positive correlation, so I can see that, hold on, where's my line thing? A positive line would go through them, okay? But it's not very tight. So if I were to say, what's the correlation? It's a positive line, so it would have to be between 0 and 1. It's not a positive 1, because a positive 1 would mean my data lines line up exactly perfectly. So I would say it's more like in the middle. So it's probably about a 0.5 on an R scale. Okay? If I put those data points, they look pretty close to a perfect negative line, which means their correlation would be about a -1. If I put data points on like this, there's not a positive or a negative correlation here, so their correlation coefficient would be a 0. And if I put data points on like this, you can see between the first one and the last one, this set is a little tighter correlated than this set. So this correlation coefficient would be closer to 1, but it's not a perfect line, so 0.75. And like, we're just guessing right now. We're going to be able to calculate those, and I'm going to show you that tomorrow on the calculator. Switching completely, we need to look at graphing inequalities and remind you how that happens. So the first thing I'm going to do, well, this one I'm actually going to solve by intercepts. Okay, I know the x-intercept is 0 something. No. The x-intercept is something 0. The y-intercept is 0 something. Okay? So my x-intercept, if I plug in 0 for y right there, this whole term will go away. So I'll be left with 3x, I'm just going to do equals 12. So x would be 4. So 4, 0 is my x-intercept. Now, on the second one, if I plug in 0 for x, I'm left with, this term goes away, I'm left with -4y equals 12. So the y-intercept would be -3. So if I connect those 2 points make a line. Connecting them, remember, a greater than or a less than is going to be a dotted line. A greater than or equal to, a less than or equal to is going to be a solid line. This doesn't have an equal to sign, so this is going to be a solid line, a dotted line. Now I need to figure out shading. Here's the problem with graphing by intercepts. It looks like I want everything greater than 12. But if I think about the math in this, when I solve for y, I would divide through by a negative, which would flip this inequality, which would mean I want to be less than 12. I'm going to put my pen on my y-intercept, and if I want less than y, I want down here. So I'm going to shade less than. Okay, I don't do this whole scribble thing because if we do a system of inequalities, it will be messy. Okay, so I just want the lines. Now, for those of you that just got lost, I'm going to solve this equation for y. And if I solve this equation for y, I'm going to get negative 4y is greater than negative 3x plus 12. When I divide by the negative 4, I'm going to get y is less than, 3/4 x minus 3, which would give me the current line. Okay, and let's just look at what a system of inequalities. A system just means more than one equation. And what would it look like if I put more than one equation on? So the first one is an absolute. So I'm going to start with my parent function. -2, absolute value. -1, absolute value. 0, 1, 2. I see that my a is a -1, so I'm going to multiply all these by -1. I'm going to subtract 2 from my x's. And I'm going to subtract 1 from my y's. And I'm now going to plot -4, -3, -3, -2, -2, -1, -1, -2, 0, -3. If I look at this, I see that I have a equal to. If there's a line, it's a solid line. That's the rule of thumb. So I'm going to connect this. And again, this is less than, so I put my arrow on the y-intercept, and I want to go less than, which means I'm going to be shading down, which means I'm going to be inside the absolute value graph. And again, I don't scribble. I'm going to look at this next graph. Y is greater than or equal to -7. I know that y is a horizontal line through 7. It's a solid line, so I'm going to make this solid line. And if I want to be greater than or equal to, I want to be going up this y-axis, so I'm just going to shade in a different direction above this line. So I can see that my shading has now narrowed down to this intersection area. Now I want x is less than 8. Let's pick a new color. There we go. Okay, x is less than 8. I know that's a vertical line through 8, but I also know that it is a dotted line. So 2, 4, 6, 8. So this is going to be a dotted line. It won't really affect my shading because I'm going to shade, I want less than, which means I want this way. So I could shade all of this if I want to, but I also know that then the only thing that'll be shaded here is here. So only points within this area will be considered solutions, and on the lines, because the pink line and the blue line are included. No solutions outside here or under here will be considered solutions.